Hi everybody, we come back with this video. Last time we see the parallel operation of AC generators, but today we discuss about the definition of transformer, the principal operation of transformer, and also we see types of transformer, construction of transformer, and task performed by transformer is our today's main topics. Please don't forget to subscribe, share, comment this video. Now we see each of them in details. In first slide we see a transformer is a static device that changes AC electric power at one voltage level primary to AC electric power at another voltage level secondary through the action of magnetic field without change in frequency. That means the frequency in primary winding and in secondary winding is equal. If it is 50 Hz, it is constant 50 Hz, or if it is 60 Hz, it is 60 Hz. But the amplitude or the magnitude of the voltage in primary side and in secondary side is vary. It also transformer consists of core assembled of laminated ferromagnetic core and two or more coils of wire wrapped around a core. Core is a rod of magnetic flux. A transformer without core like a ship without compass. Why we say many times transformer is a static device. Transformer is or a transformer has not a rotating part, hence it is not often or it is often called a static device because of no rotating part. Although a transformer is not classified as an electrical machine, the principle of its operation are fundamental for the induction motor and synchronous motor. Transformer is not classified as electrical machine because transformer has not a rotating part, but induction motor and synchronous motor or synchronous machine has a rotating part. But in principle, both of them are the same as transformer. If we see the second topics, the principle of operation of transformer. A transformer operates on the principle of mutual inductance between two inductively coupled coils. That means the primary and secondary windings are not coupled electrically, but it is coupled in magnetic induction. The primary and secondary windings are coupled by magnetic induction, that is, no electrical connection between the primary and secondary windings except auto transformer. In auto transformer, the primary winding and the secondary winding is connected electrically. The primary winding is connected to an alternating voltage or an AC voltage produce an alternating flux. Because of connecting a primary winding to alternating voltage, an alternating flux is produced. But the magnitude or the amplitude of flux produced on primary winding is depend upon the primary voltage, frequency, and number of turns. The transformer shown figure below is illustrated in different symbols. The first one is N1 and N2. N1 stands for number of turns in primary, N2 stands for number of turns in secondary. V1 stands for number of voltage in primary and V2 stands for number of voltage in secondary. I2 and I1 stands for number of or the current flow in primary and secondary. That is, I1 stands for current flow in primary winding and I2 stands for current flows in secondary winding. The relation of these three parameters shows or indicates the simple transformer ratio. As we see here, N1 over N2 is equals to V1 over V2 is equals to I2 over I1 is another option. But if we reciprocal this one, we get N2 over N1 is equals to V2 over V1 is equals to I1 over I2 is indicate the simple transformer ratio. As you see in this figure, P stands for the primary windings of a transformer which is connected to supply voltage, and S stands for secondary winding which is connected to load or output winding. The transformer winding connected to power source is called the primary winding. That is, P stands for the primary winding which is connected to supply or input winding. S stands for secondary winding which is connected to or called output winding. Types of transformers. Transformers are classified based on the following bases. The first one is the position of the winding with respect to core. Under this one, there is two types of transformer are found. The first one is core type transformer and the second one is shell type transformers. These two transformers are the basic types of transformers. Based on transformation ratio, transformer also now divided into two. The first one is a step-up transformer and the second one is a step-down transformers. Step-up transformer and step-down transformer as well as core type and shell type transformers are discussed in next slides. Types of service. Based upon these, transformer is also classified into two. The first one is power transformer and distribution transformers. Construction of transformer is our third topics. A transformer has the following main essentials. That is the electrical winding and laminated core. Whether a transformer is huge or very small, but these two parameters or these two essential parts must be found on transformers. The two basic types of transformer construction are shell type and core type transformers. The two types of construction different in their copper conductor and the iron cores. The primary and secondary coils are wound on the core. Both the core and shell types are used and selection is based upon one voltage rating, 2 kVA rating, third weights of transformer, in fourth case insulation stresses, in fifth case mechanical stress. Last one is heat distribution. Core type transformer consists of single rectangular or L-shaped laminated piece of steel with transformer windings wound around two legs of magnetic core. To reduce the leakage flux problem in core types of transformer, engineers placed half of the low voltage winding over one leg and other half over second limb. The copper conductor surrounds the core. It has longer mean lengths of core and shorter mean lengths of coil turns. It requires more iron core and fewer conductors for coils. Has more rooms. Core type transformers has more rooms for ventilation. It is better adapted for high voltage. This figure indicates the core type transformers. Second one is shell type transformer. Consists of three-legged laminated core with the winding wrapped around center legs. Core surrounds a major parts of the windings. It has better provision for mechanically supporting and bracing the coil. The core is either E or F-shaped and stacked to give rectangular a figure below. Look, to reduce the amount of high voltage insulation required. This is a shell type transformers. Transformation ratio. The winding used to circuit with the higher voltage is called high voltage winding, or the winding which is connected to a circuit with higher voltage is called high voltage winding. The winding which is connected to the circuit with lower voltage is called lower voltage windings. So a transformer has high voltage winding and low voltage winding. The voltage which higher than the lower one is said high voltage, its primary side or secondary side. A transformer is termed as either a step up or a step down transformer, depending upon the voltage in the windings. If the secondary voltage is less than the primary voltage, the transformer is called a step down transformer. Don't forget, if the secondary voltage is less than the primary voltage, the transformer is called a step down transformer. The number of turns in the primary winding is more in number, but the cross-sectional area of the wire is thin. If the secondary voltage is higher than the primary voltage, the transformer is called a step-up transformer. Look, if the secondary voltage is higher than the primary voltage, the transformer is called a step-up transformer. The primary winding is less in number, but the cross-sectional area of the wire is thick. Notice, the transformer is termed as a step up or a step down only when they are connected to the supply. In another word, A step-up transformer can be a step-down, or a step-down transformer can be a step-up. We can use a step-up transformer as a step-down transformer. But don't forget the high voltage winding and the low voltage winding is identified. And also I give you presentation on next video based on upon this. Types of service under this power transformer. Power transformer is installed at various power stations for generation and transmission of power. It acts as step up or a step down transformer for increasing and decreasing the level of voltage as per the requirement. And it is also used as an interconnection between two power stations. Distribution transformers. The distribution transformer is used to bring down or step down the voltage and the current level of transmission line to predefined level, which is called safety level for the end users or consumers in domestic and industrial purpose. The last one is task performed by transformer. The most transformers or the task performed by transformers are: 1. It converts electrical power from generating voltage of 11 kV, 13.5 kV, 15 kV. It converts step up the voltage. In second, reduce the voltage at safe level. That is step down. Impedance. In impedance transformation device to allow maximum transfer of power from the input circuit to the output device. It means impedance transformation device to allow maximum transfer of power from input circuit to output device. Electrical isolation. This means to isolate one circuit from another or isolating DC while maintaining AC continuity between circuits. These all are for today. Thank you for watching this video. Don't forget to subscribe, like, share, comment this video. Your like, shares and comments are support us. Thank you. See you in next video.